The last of the three questions that I wanted to go over from the test is also a question where I think we were tripped up because of the calculator, but it was actually on the second section where you are allowed to use your calculator. So take out your calculator now and compose these functions and put them into the calculator. Okay, so if you do the composition, this is what you should end up with. And if you put that into the calculator, this is what it would look like. So now that you've refreshed your memory, right away you may notice some people made a mistake because the g function had to be plugged in two different places. And so some people got tripped up just because they didn't realize or understand that. But you're with me, you've got it plugged in both places. Let's take a look at what the graph looks like. This is the graph on a TI-83. The 84 gives me a slightly different picture. Both of them are misleading in a certain way. So pause the video and adjust your window. We want to kind of get a closer picture of what's going on right in this area so we can start to tease out what we should trust or not trust. Here's my closer view on each of the different calculators. And what I notice they have in common is that in both of them, the function seems to start right around 3. It doesn't exist before 3. So that suggests that the domain is going to start at 3. Now, what the calculator can't tell me is whether or not 3 is actually part of the domain. And this is where, even on a calculator section, you need to go back to the equation and trust what you really know. So first of all, looking at my answer choices, I'm going to go ahead and eliminate answer choice B. It's pretty clear that this function doesn't include negative numbers in its domain. When we looked at that graph, there was nothing going on over here. So B's out. Looking at the other ones, sure enough, they all start at 3. Some of them include 3, and the rest of them don't. Looking at my equation instead of the graph, the way that I know whether I should have a closed bracket or an open bracket is based on whether or not I'm allowed to plug in 3. So let's try it. If I plug in 3 on the bottom here, I get 3 minus 4 is -1, and 1 over -1 is -1, plus, if I plug in 3 right here, 3 minus 3 is 0. And I'm allowed to take the square root of 0. That just equals 0. So from what I can tell, there's no problem with 3. In fact, I'm allowed to plug in 3 to this function. So it should be in the domain, which means this is most likely the answer, because 3 should be included. Now, we should check a little more than that before we go with E. So going back to the graphs, the next thing I notice is that there's something weird going on at 4. And the TI-83 shows me a straight up and down line. The TI-84 doesn't show me anything. And that's because graphing calculators really are not very good at handling asymptotes. And you may have guessed by now that this function has an asymptote at 4. Now, the 83 gives you the straight up and down line, which is confusing because you might think that that line is part of the function, which it's not. The 84 shows you a gap, which is more accurate, but it makes it very hard to tell where the asymptote is. Like, I can't really tell if it's at 4 or if it's at 4.1. It could be a decimal asymptote. So again, we can't trust the calculator to give us the full picture. We have to go back to the equation. An asymptote at 4 would mean that if I plug in 4, something goes wrong. And sure enough, if I try it, 4 minus 4 on the bottom of a fraction gives me an undefined value. In other words, I'm not allowed to plug in 4, which means 4 is not part of the domain, which means I should eliminate any domains that include 4. Well, A includes 4 because 4 is between 3 and infinity, so A's got to be wrong. C includes 4 because it's got a closed bracket at that dot. D and E don't include 4. D is saying you exclude 4 but continue on forever, and so is E. Now, we've already seen that E is the correct answer because the difference in how it treats 3, but we now also understand why it has 2 pieces instead of being A or C, making E the correct answer choice. Here's one for you. Pause the video while you get this one graphed. The composition's pretty simple. Here's what the TI-83 shows me. And if you just want to double check you have your parentheses right, that's what it should look like in the y equals. And then looking at the graph, this is the standard window. It looks like the graph is kind of a negative square root function, which is interesting because actually, and the TI-84 shows me the same thing, but they're actually both lying to you here. Just like the graphing calculators are bad at showing asymptotes, they're really bad at showing vertical lines. So this graph has an asymptote actually, and you can see it if you zoom in. So on the 83, I'm going to zoom in, and I'm going to move my cursor so that I zoom in kind of on this region, and then just press enter here. And the curious thing is when I get really close to it, the calculator will show me that it continues to go up. But from far away, the image doesn't represent that fact. So again, you have an idea from your calculator, but the ultimate call has to come from your common sense. When I look at my answer choices, it seems pretty clear that we're starting at 5 and continuing on. So I'm going to go ahead and eliminate C and D, because these both have the domain continuing left to negative infinity, which it doesn't. It clearly doesn't. Now, of my other answer choices, 2 of them start at 5, 1 of them starts at 0. Again, I can trust the calculator when it shows me that the graph is over here. I just can't trust what exactly is happening on the edges. So I can trust that 0 is not in the domain, that it starts somewhere around 5. I'm going to eliminate answer choice E. Now the difference between A and B is, do I include 5 or not? And my calculator is not helpful for that answer. Neither version, in fact. Even if I see the asymptote, it's very unclear whether the asymptote is at 5 or a little bit past 5 or what the deal is. So let's look at the equation. What would happen if I plug in 5? Am I allowed to? Well, 5 minus 5 is 0. And the square root of 0 is okay. I can do that. That's just 0. But the problem is 1 over 0 is not okay. So in fact, if I plug in 0, the function is undefined. Sorry, if I plug in 5, the function is undefined, which means that 5 is not in the domain, which means that we want an open parentheses at 5, making the answer A. Here's the next one for you. Again, pause the video and take a stab at answering it by yourself before I explain. All right, so on the screen you can see the composed versions. When you put that in the calculator, this is what your parentheses should look like, so just double check that you have both sets of parentheses in the right spots. And on the TI-83, here's the picture. Oh no, I just cleared it, hang on. Okay, here's the picture that I get on the 83. This is just the standard window. It looks pretty messy, so I should adjust my window. I want to see kind of this section right here. I could zoom, or I could just adjust the window to go from, I don't know, let's say -3 to 6. And we'll zoom in a little bit here. We'll do -3 to 5. And this gives me, a closer picture, and it is still looking pretty weird. Now, you may be familiar with this from the last one we did, and here's the 84. But same idea. So both of my graphs seem to be starting around -1. And I can trust the calculator with the general setup of this. So I'm looking for a domain that starts at -1, which means I can rule out option E pretty quickly. But of the other ones, it's not clear whether -1 itself is included or not. And I'm going to go to the equation for that. If I plug in -1, well, in the fraction, -1 right here would be 2 times -1 is -3, minus 1 is -3 there, and that's fine in the fraction. If I put -1 into the square root symbol, 2 times -1 is -2, plus 2 is 0, and the square root of 0 is fine. So it's okay for -1 to be in the domain, which means I'm going to eliminate B, which said that -1 was not in the domain. Of my 3 other options, the first option means that the domain starts at -1 and keeps on going all the way to positive infinity. Graphically, that would mean that the function starts here and has no gaps or breaks until there. Option C is saying it starts at -1 and then it has an asymptote or a hole or something at 1/2 because it's not in the domain, and then it goes on forever. Option D is saying it starts at -1, and then it has an asymptote or a hole or something at 2/3, and it goes on to infinity. When I compare these options to my graphs in the calculator, it seems pretty clear that we're going to be looking at C or D, because there is something going on somewhere right here between 0 and 1. And this is an asymptote. Your graphing calculator doesn't really know how to show it, so the 83 is going to give you a line and the 84 is going to give you a gap. But you can't know where exactly the asymptote is just looking at these. In fact, even if you trace, there's no way to trace what that number is because you can trace on either side of it, but never right at the asymptote. So that's as much as the graphing calculator can help us. It can help us eliminate A, but I need to figure out somehow where the asymptote is. And this is where we go back to the equation. So asymptotes happen when you have a 0 on the bottom of a fraction. And the question is, what number would I have to plug in for x in order to make the bottom of this fraction equal 0? Maybe if you are good with decimals, you would convert 1/2 to a decimal and plug it in right there. Maybe you would convert 2/3 to a decimal and plug it in. Or, I like the algebra, so I'm going to say, okay, what number would make 2x minus 1 equal 0? Or maybe a better way to say it is that 2x minus 1 is not allowed to equal 0. If I solve for x, add 1, that means that 2x can't equal positive 1, which means that x can't equal 1/2, which is why C is the right answer choice. 1/2 is not in the domain of this function, because if I plug in 1/2, I'm going to get 0 on the bottom of a fraction. Here's the last one for you. Just like before, do the composition, plug it into the calculator, and see if you can answer this one without me, and then I'll explain. So my favorite thing about teaching you guys is that you can handle me throwing new things at you, although I realize sometimes that causes frustration. If you got this one wrong, don't worry, I'll show you the little thing you're missing. If you got it right, props to you, you rock, keep going. There's the composition, solving it out. This is what it looks like in the calculator when you have all the parentheses. And you're used to by now looking at the graph and saying, okay, there's a mess. And I understand that the mess is an asymptote that the calculator doesn't know how to show me. Here's the 84 version. And then if you got it wrong, I'm guessing that you had the domain just starting right at that number. But maybe you didn't. Maybe you went to the equation and said, well, I'm looking for a domain that starts somewhere around -5. And there are a bunch of answer choices with that as an option. B and E I'm going to rule out right away, because the graph doesn't go all the way to -infinity. So those are clearly wrong. Now the question is whether -5 is part of the domain or not. This one would be part, those say not. Looking at the graph, it kind of looks like it starts right there at -5. But we don't know if it's an open or closed circle until we look at the equation. If I plug a -5 into the bottom of the fraction, -5 minus 3 is -8, and that's perfectly fine. So what happens if I plug in -5 into the natural logarithm? Well, ln of -5 plus 5 is the same thing as ln of 0. Sorry about the handwriting here. And it turns out that the natural logarithm of 0 doesn't exist. How do we know this? Well, one way we know this is because the meaning of the natural log is like saying e to what power equals 0. And the answer is no power. You can't take a positive number raised to power and get 0 out. You can put 0 as the exponent, but you get 1. Another way you could see this, since you do have a calculator in front of you, is if you quit out of the graph mode and try to do the natural log of 0, your calculator tells you, oh, there's a domain problem. And in fact, if you go to, it shows you that that's no good. It's going to be an error every single time. So -5 is not in the domain because this does not exist, which means that I can rule out C. Okay, we're doing really well. The difference between D and A is that D says the domain starts at -5 and keeps going, but A says there's an asymptote at 3. So A it is.